Hello everyone, welcome to this YouTube channel. Well, today we'll be looking at a very interesting question from Cambridge Physics, Paper 4, 2024 October number variant 4.3. So we'll look at question 1b, Roman 1 today. Actually, this upper part of this question is not really necessary to what we're gonna answer now. So let's jump straight to Roman 1. By reference to forces, explain why the orbit of the satellite is circular. Alright, so allow me to illustrate this using a diagram. So we have a planet here, nice round planet, and the dotted dotted circle around the planet is the orbit of the satellite, and this is my beautiful satellite. Alright, now I know it doesn't look really like a satellite, but you get the idea, right? Okay, so this satellite is actually moving around the planet in its orbit in a constant speed. So the first things first, the satellite is actually moving around the planet at a constant speed. That means it's moving at the same speed, probably moving at 30 kilometers per hour. It's moving at 30 kilometers per hour throughout its motion. However, the velocity is changing. Question is, why is the velocity changing? Because the direction of velocity is changing. At this point, the direction of velocity is tangent to the circular path. At any point on the circle, the direction of velocity will always be tangent to the circular path. So at this point, this is the direction of velocity. At this point, this is the direction. At this point, this is the direction, and so on and so forth. Realize that the direction are actually changing. And as far as we are concerned, velocity is a vector quantity. And vector quantity consists of magnitude and direction. And since the direction is changing, it means that the velocity is actually changing. In other words, the magnitude of velocity is constant, but since the direction of velocity is changing, we conclude that the velocity is actually changing. So what if the velocity is changing? When there is a change in velocity, there is something called acceleration. Why? Because acceleration means rate of change of velocity, or in other words, change of velocity over time. Now, the next question you must ask yourself is, which direction is the acceleration pointed at? Is it parallel to the velocity, or is it perpendicular to the velocity? You might want to pause the video and think about it for a while, but the answer is, it's actually perpendicular to the velocity. Why, you might ask? Because, remember the first thing we said, the speed is constant. If the acceleration is in the same direction of motion, or in other words, same direction as the velocity, the speed will not be constant. The speed will start to change. So we don't want the speed to change. That's why the acceleration is perpendicular to the velocity. Now, this acceleration is known as centripetal acceleration. To be more specific, it is known as centripetal acceleration. This centripetal acceleration is an acceleration that is directed towards the center of the circular path. Since the satellite is moving in a circular motion, in a circular path, the acceleration that is experienced by the satellite is known as centripetal acceleration. Where does the centripetal acceleration come from? The centripetal acceleration comes from centripetal force. And where does the centripetal force comes from? It actually comes from gravitational force. Because you need to remember one thing, centripetal force is a resultant force. It's a result of a force. So for this case of scenario between the planet and the satellite, the centripetal force is a result of the gravitational force. Where does this gravitational force come from? This gravitational force is actually the gravitational force of the planet that is acting on the satellite. Because if there's no gravitational force, or in other words, if there's no gravitational pull, the satellite would be long gone in the space. But since there is a pull, that is why the satellite is orbiting the planet. And for it to orbit in a circular motion, this gravitational force provides the centripetal force. And since you have a centripetal force, which in turn gives you centripetal acceleration. Do you get the idea? So this is the thought process that we go through when it comes to answering this type of question. First thing I say, constant speed. Okay, nice, constant speed. Next thing, velocity is changing. Why? Because the direction of motion is changing. And since the direction of motion is changing, velocity changes. When this velocity changes, there's acceleration. And when there's acceleration, there must be a force. And in this case, to be specific, the acceleration is centripetal acceleration. Why? Because the satellite is moving in a circular motion. The acceleration that acts towards the center of the planet but doesn't change the speed, only changes the velocity, is known as centripetal acceleration. And this centripetal acceleration comes from where? It comes from the centripetal force. Centripetal force comes from a gravitational force. Because like I say, centripetal force is a resultant force. It's a result of a force. This gravitational force comes from where? It's actually the gravitational force of the planet that acts on the satellite. It's like a pull, gravitational pull. That is why it's moving in an orbit. What causes satellite to move in a circular orbit? It's the centripetal force. This gravitational force provides the centripetal force, which in turn provides centripetal acceleration, causing the satellite to move in a circular motion. So, the first answer we write is the gravitational force is perpendicular to the direction of motion. This is our gravitational force. In other words, this is our gravitational force. Like I say, gravitational force is the one that provides centripetal force. And when you have a centripetal force, you have a centripetal acceleration. I denote AC as centripetal acceleration so that you can understand. So in this case, when it comes to calculation, right, let's say they ask you to derive a formula. Usually when you want to derive a formula, this equivalent equation comes in handy, because gravitational force provides centripetal force. Usually when want to derive equations for period, you will use this type of equation. Why? Because like I said, gravitational force provides centripetal force. So that's why our gravitational force is here, our centripetal acceleration is also here. That means our centripetal force is also in the same direction, acting towards the center. The next answer is this gravitational force provides centripetal acceleration. Well, that ticks the question. This is for 2 marks question. If the question has 4 marks, you might need to explain that it's constant speed and the velocity is changing, causing it to have acceleration. You might need to explain that. But since it's 2 marks, just straight to the point. The force is perpendicular to the direction of motion, or you can also say velocity. Then why is it circular? Because the gravitational force is the one provides centripetal acceleration, causing the satellite to move in a circular motion. Just nice, easy as that, you will get your beautiful 2 marks. There you go. So this is the thought process that should occur to you when you answer instead of question, so that you are clear on what the question is asking. Alright, we have come to the end of the video. That's all for today. And if you have any questions about this, please let me know in the comments. I'll try my best to answer. And if you have any other specific physics question you would want me to try, I would love to try. Just let me know in the comments. So I hope this video helps you to understand the question better and enhance your understanding on this concept. Therefore, see you in the next video. Alright, bye bye and have a nice day.